Between 1965 and 1973, thousands of American soldiers in Vietnam fell victim to an enemy they never saw coming. Concealed beneath jungle trails and rice paddies, the Viet Cong deployed one of history's most extensive networks of improvised traps and tunnel systems. Punji stakes, tripwires, pitfalls, and explosive devices accounted for nearly 11% of all U.S. casualties during the conflict. But this wasn't a static problem. Today, we examine how American forces systematically adapted their tactics, technology, and training to counter an invisible battlefield threat. The use of booby traps wasn't new to warfare, but the Viet Cong refined it into doctrine. Operating with limited industrial resources, North Vietnamese and Viet Cong forces relied on asymmetric tactics to offset American firepower superiority. Traps served multiple strategic purposes. They inflicted casualties, slowed patrol movement, created psychological strain, and forced U.S. units to adopt predictable behaviors. Common trap designs included punji pits lined with sharpened bamboo stakes, often coated with human waste to cause infection. Tripwires connected to grenades, artillery shells, or swinging log traps were hidden along trails. Explosive devices ranged from modified hand grenades to repurposed American ordnance. The Cu Chi Tunnel Network, stretching over 150 miles near Saigon, provided concealment for trap construction, ambush preparation, and rapid withdrawal. American doctrine initially emphasized mobility and firepower. Standard infantry patrols moved quickly through unsecured terrain, relying on superior medical evacuation and air support. But by 1966, trap-related casualties forced a reassessment. The U.S. military began implementing layered countermeasures across tactical, engineering, and intelligence domains, patrol tactics, and movement discipline. The first adaptation was tactical. Infantry units reduced patrol speed in high-risk areas, with pointmen advancing cautiously while scanning for disturbances in soil, vegetation, or trail surfaces. Soldiers learned visual recognition patterns, unnatural ground discoloration, fresh digging, bent foliage, or tripwire shine under certain light angles. Walking formations changed. Instead of single-file columns that funneled troops into kill zones, units adopted staggered or diamond patterns to distribute exposure. Established trails were avoided when possible. When movement along trails was necessary, soldiers walked on the edges rather than in worn center paths where traps concentrated. Engineering and detection methods. Combat engineers deployed specialized equipment for trap detection. Metal detectors identified buried ordnance, though their effectiveness was limited by Vietnam's mineral-rich soil and the widespread use of non-metallic punji stakes. Portable mine prodders, thin metal rods pushed into the ground at shallow angles, allowed soldiers to physically probe suspected areas without applying full weight. Engineers developed rapid neutralization techniques. Once identified, traps were marked with colored smoke, flags, or spray paint. Explosive traps were destroyed in place using controlled detonations or small arms fire from a safe distance. Punji pits were filled or bridged using local materials. Bangalore torpedoes and mine-clearing line charges saw limited use for clearing known trap belts ahead of major operations. However, these methods were resource-intensive and telegraphed U.S. intentions, reducing tactical surprise, protective gear, and medical response. The military issued flak jackets and reinforced boots, though neither provided complete protection. Flak vests reduced fragmentation injuries from above-ground explosives, but were less effective against ground-level blasts. Boot insoles were thickened, and some units experimented with steel-reinforced footwear, though the added weight reduced mobility in difficult terrain. Medical evacuation procedures adapted to trap injuries. Medevac helicopters were positioned for rapid response, reducing the time between injury and surgical treatment. Field medics received enhanced training in treating puncture wounds, preventing infection, and stabilizing blast trauma victims. Antibiotic protocols became standard for any penetrating injury due to contamination risks, tunnel warfare, and specialist units. The discovery of the Cu Chi tunnels prompted the formation of specialized units. Tunnel rats, volunteers who entered confined underground complexes, developed unique procedures for neutralizing subterranean threats. Armed with pistols, flashlights, and communication rope, these soldiers mapped tunnel networks, destroyed supply caches, and collapsed passages using explosives. Above ground, chemical agents and smoke grenades were used to flush out tunnel occupants or identify hidden entrances through ventilation shafts. Engineer units employed tunnel denial operations, pumping acetylene gas or tear gas into known complexes before detonation or permanent sealing with explosives and bulldozers. Intelligence and counter-guerrilla strategy. Intelligence gathering became central to reducing trap casualties. Civil affairs units worked with local populations to identify trap locations, though this approach was complicated by Viet Cong intimidation and uncertain civilian loyalties. Captured documents and prisoner interrogations provided insights into trap construction methods and placement doctrine. Reconnaissance teams conducted deliberate route clearance missions ahead of larger formations. These small units moved slowly, documented threats, and established safer corridors for follow-on forces. Pattern analysis identified high-risk terrain features. Stream crossings, natural choke points, and abandoned villages frequently contained concentrations of traps. The Phoenix program, aimed at disrupting Viet Cong infrastructure, indirectly reduced trap effectiveness by targeting the personnel responsible for construction and emplacement. While controversial for other reasons, operations against logistical networks limited the resources available for trap production. Despite these adaptations, complete mitigation proved impossible. The Viet Cong continuously refined trap designs in response to U.S. countermeasures. Wooden or bamboo spike traps evaded metal detectors. Delayed action explosives circumvented initial sweeps. False tripwires distracted attention from actual triggers. Tactical adaptations had operational costs. Slower patrol speeds reduced the area units could cover, allowing enemy forces greater freedom of movement. Avoidance of trails sometimes pushed soldiers into worse terrain, increasing non-combat injuries and exhaustion. The psychological burden of constant vigilance contributed to stress casualties. Resource allocation also posed challenges. Specialized equipment and trained personnel were never available in sufficient quantities across all operational theaters. Units in remote areas relied on improvised solutions and on-the-job learning, which varied widely in effectiveness. The U.S. military's response to Viet Cong traps demonstrates the challenge of asymmetric warfare adaptation. Through incremental improvements in tactics, engineering, protective measures, and intelligence, American forces reduced their vulnerability to a persistent threat. Trap-related casualty rates declined in units that implemented comprehensive countermeasures, though they never disappeared entirely. This adaptation cycle illustrates a fundamental military reality. Technological and numerical superiority don't eliminate the effectiveness of low-cost, locally produced defensive systems when employed with knowledge of terrain and enemy behavior. The lessons learned in Vietnam's jungles would later inform counter-IED doctrine in Iraq and Afghanistan, where a new generation faced hidden threats beneath desert roads. The war beneath the war continued until the American withdrawal, a silent contest of ingenuity between those who set traps and those who sought to survive them.